Determining the polarity of a bond is determining the difference in the electronegativities of the atoms involved in a bond. So just as kind of an example there, the electronegativity difference between these two atoms is 0. Their values, whatever their values are, minus one another is going to be 0. Their electronegativity says that this bond, these two electrons, are going to spend about equal amount of time between the atoms right there. But if we have elements like H and Cl chlorine, they have a difference in their electronegativity. Now, thinking about their electronegativity, you can do the math. Hydrogen and chlorine are in these, respective places on the periodic table. This hydrogen, fitting the electronegativity trend on the periodic table, placing hydrogen above carbon has a fit much better in there. If we take the difference or subtract these two electronegativity values, we would get a difference greater than 0.4. And that's kind of the line in the sand that chemists say, like, hey, this is a polar bond, meaning it's a weaker bond. And to display that picture, we would say that, like, hey, there's a bond there, it's a covalent sigma bond, but those electrons are spending, say, more time around the higher electronegative atom. So to determine whether a bond is polar or is weaker, or which element they're spending the more time around, you look these numbers up, their electronegativity values, subtract them from one another, and if you get a difference greater than 0.4, we'd say it's a polar bond. Thank you.